Hello and welcome back to Azure Terraformer. Today we are going to be taking the next step in our Minecraft Terraform Azure saga and deploying those Minecraft modules that we built to multiple regions. So in order to do that, we're going to have to add additional replication for our virtual machine images using our shared image gallery, which is one of the cool features of that resource. To make it super simple to propagate your virtual machine images and make them available to you across lots of different Azure regions, so that you can achieve multi-region deployments very easily. And then what we're going to do is we're going to use the count meta operator within Terraform, and I think this might be the first time that we do that in this channel. So we're getting to some, I'd say, intermediate level to advanced level topics here using the count meta operator. We're going to be iterating across a collection of region names to deploy our Minecraft server out to all of the regions that we want to deploy to. Please, before we begin, the obligatory, please smash that like button and hit subscribe and that notifications bell so that you can be aware of when the next video drops, because I got a whole lot more content primed and ready. But without further ado, let's get going. So the first thing I'm going to do, because this does take a little bit of time, is I'm going to pop over to my shared image gallery and I'm going to replicate my virtual machine image across a number of different regions. So here I'm going to go grab my latest version and I'm going to update replication. I'm going to add West US 2. I'm going to add West US 3, and then I'm going to hit save, and it's going to update that. Now I'm going to do the same thing for my blob fuse image. I'm going to go grab my latest image, update replication, and I'm going to add West US 2 and West US 3. We're just going to hit save. And this is going to cook. So the replication happens in the background, and once it's ready, it's going to say completed. But while it's doing that, I'm going to go ahead and make the code changes and review them so that when this is done, we'll be ready to go. So let's pop over to the code. So now the thing that, so when you're designing modules and when you're using modules, you have to decide, is this complexity that I want to embed in the module, or is this complexity that I want to that is outside the purview and the responsibility of the module. And so the way I like to design modules is I like the module to be very focused on doing one task. And so in this case, my Minecraft module is, for both of them, my local storage module and my blob storage module for Minecraft, they have one task. I am going to build a Minecraft server that uses local storage in this region. Or I'm going to build a Minecraft server with a blob storage backend in this region. That is the focus of that module. And in this case, I think adding additional regions should be an external factor that's imposed on that module. And so rather than embedding in the module, like adding a variable called like an array of locations or something like that, I prefer that sort of complexity is external to the module. That means that module can remain relatively simple and focused. And if somebody wants to use it in its simplest manner, they don't have to worry about like an array of locations, if it doesn't matter to them. But if they do want to deploy that module to a multitude of regions, then they have that option as well. And so what we're going to do, we can do that extremely simply by going into here and simply saying, declaring a locals variable, and this is going to be our regions array. And this array is basically going to have all the regions that we're going to deploy our modules to. West US, West US 2, West US 3. Okay? And I mean, I could leave that on one line. I tend to like to, punch it out like this so that it becomes very, very easy to see and read, what's happening here. Now, modules, just like any resource or any data source, can use a meta operator called count. And another reason why I like to do this outside of the module rather than inside of the module is if I were to do this, if I were to impose this complexity inside the logic, every single resource in my module would have to have this count meta operator. But because I'm keeping this complexity outside of the module doesn't have to care about this like complexity at all. The module simply operates under the assumption of this is my location, this is my resource group, this is my yada yada, right? And so it doesn't have to worry about it. So in this case, all I'm going to do is I'm going to set the count, and the count is going to equal to the length of my regions array. And what that's going to do is basically behind the scenes, you can't see it in the code, but Terraform is going to take the module on line 9, and it's going to actually create 3 instances of this module and provision 3 instances of this module. And so what that will look like is all of the resources inside this thing are going to be iterated that many times. Now, in order to avoid conflicts, and in order to adjust the deployment plan for each of these modules, we don't want all modules to go to the same location as our resource group. So what location do we want them to go to? We want them to go to a location that's relative to the current count. So just in your mind, think of, in the back of your mind, there's this count index. So if I go locals.regions array, and then I treat that as an array, the count.index is a special attribute when you're using the count meta operator that allows you to specify at a certain count index, 0, 1, 2, 3, 4, whatever the count is. Of course, this count is going to be like 3, right? Or actually 2, because it's a 0-based array. So 0, 1, 2 are going to be the values of count. And so the first time Terraform deploys this module, the count is going to be 0, and it's going to go grab West US. So we're going to have one instance of this module that's deployed to West US. And then the next time Terraform deploys this module, it's going to be count index 1, and it's going to deploy this module to West US 2. Now, because I didn't change resource group, all this stuff is going to get jammed into the same resource group. Because I didn't change the name, all this stuff is going to get jammed in with the same name. That means I may have conflicts because my VMs are going to have the same name. So what I need to do is I need to also use string interpolation here and just embed count.index on the VM name to make sure that it's different. But these other things, they can be the same. Like I want to use the same image, Packer image. I want to use the same gallery. I want to use the same subnet. I want to use the same SSH key. So we're good to go. Now, again, now that I've got these regions set up, it becomes extremely easy for me to do this. All I have to do is change the location and change the name by embedding this count.index in there. Got some screen problems. Okay. And let me git checkout main, git fetch all, git pull, git checkout b feature multi-region. Okay. And now we're going to check this into multi-region. Okay. And that is it. I mean, literally, the array declaration is technically 3 or 4 lines of code, but that's essentially 1 line of code that I've just split up into 4 lines. 1 line of code to set the array, and then 1 line of code to set the location to key off of the correct index of the array, and then 1 line to modify the name so that it doesn't conflict with other VMs that we deploy, and that's pretty much it. So yeah. So let's go. Looks like our replication is completed. So let's go submit a pull request and let's see how this thing works. So we're going to go multi-region, and now we're going to have, not only we're going to have Minecraft server in West US, we're going to have 2 more Minecraft servers in West US 2 and West US 3. And in fact, in total, because we're deploying 2 Minecraft servers already, a blob storage and a local storage version, we're going to have 6 Minecraft servers, 2 in each of the 3 regions that we specified. So this will be really interesting. Oh, so we have a bug. Oh my lord, typo. This is also a language inconsistency I find with HCL. Is when you declare a local, you put it in a locals block, plural, locals, plural. When you reference a local, you're referencing it using local, singular. So it's it's one of those things that sometimes catches me up, and today is one of those days. So local ref should be singular. My bad. But that, again, that error message, not super useful. Not super obvious, like that was the problem. But just looking at the code, just, having that question in my brain, like, what could be wrong here? What's out of place? Just remember, locals are declared in a plural locals block and then referenced using a singular local. Yep. All right, let's look at this plan. There should be a lot more stuff going on. Because again, if you remember, with our blob storage account backed Minecraft server, we're going to blow out a storage account, a container, a managed ID, a role assignment, everything. And we're going to do that for every region now. So here we go. And even the original region has to be destroyed, because remember, we modified the name of the virtual machine and the name of everything to have that index in it. And because we embedded that name in everything, in our storage account and all the things, pretty much everything is going to get rebuilt here. So going from single region with no count meta operator to multi-region with a count meta operator, we're going to have to, drop create. However, if I did some better planning and I, structured this module to already be deployed, based on an array of regions, then index 0 region would not have had to be deleted. And I could add an additional region, no problem. And the original region wouldn't have been dropped and recreated, because the naming conventions used within that region would have already been relegated to use that count.index. So we wouldn't have problems. So it's often good to think about if you want, what your deployment strategy is going to look like, and when you extract something into a module and when you reference a module, what context are you going to be deploying that module? Will you ever want to deploy more than one of that module? If so, you might want to think about you know how that is. Otherwise, you know, you can always like in Minecraft, it's a stateful workload, right? So me destroying this Minecraft server that I had created in West US originally I'm going to lose all my users' data, right? And that's bad. So what I would probably have done if this was an actual production workload is I probably would have stood up a new block of Terraform code that instituted the additional new regions, and then including another region for West US. And then what I would have done after that had been deployed, I would have migrated the data, done a data migration to migrate the data from the old West US to the new West US, in a sense doing a blue-green deployment. Once the data migration was completed, I would test that new West US server that's under in the new Terraform managed multi-region code, and then once I was certain the other one was no longer needed, I would remove that code from Terraform and wipe it away. So this is how you can even conduct blue-green deployments through doing multiple Terraform applies, where you iterate on your infrastructure, deploy the new thing in parallel with the old thing, do a data migration, and then delete the old thing. So, and we'll let this Terraform apply finish, and then we'll go look at our environment. So it looks like we had a failure, and it looks like it's related to maybe a nick. So let's go check that out. They should be in the same region because the nick is created using the location variable that comes in from the module. So I'd be very surprised if they are not created using that. I guess the only way we'll tell is if we go look at the Linux public and go check that out. Oh, and I think I know what's happening here. I forgot about this. So because we're deploying into other regions, our virtual network is only in one region. My bad. That's a oops. So like what I'm trying to do here is this subnet is attached to a network that's only in one region. So ultimately what I need to do is for my network, I'm going to have to use the region as well. So if I go up here and I go grab the count, I have to attach that to the network, and I have to attach it to the NSG. And then what I'm going to do is pretty much the same modification as this guy. I'm going to grab the location from that thing. So the location is like that. And then the name, I guess I'm just going to have to add some string interpolation here. So this is what am I doing? I don't want to do this. The resource group name stays the same. It's the random string that we're using. So here, I think we already have do we have a name? Yeah, we already have a name. So I'm just going to maybe get rid of the random string. Where are we at here? And just to make it a little more obvious, like what's happening. So var name and then count.index. And then here, we need to change the network that we're using to use the count.index as well. And so this should get us past that problem where we are having network conflicts. Need 3 networks. Yeah, so when you do multi-region deployments using virtual machines, you're gonna have to have a VNet in each network. Otherwise, it's not gonna work out for you. So I'm gonna have to submit a new pull request. Need 3 networks. Let's autocomplete. Of course, this won't complete if the plan fails. But man, this plan is going to be extremely destructive, and unfortunately, we're going to have to create 3 bastion hosts. So this might take a while. Oh gosh, and I made a oops. Module network. Minecraft blob storage cert. Let's go look at this. Oh yeah, and the subnet ID. I need to reference the network using an index, count.index, to get the correct subnet ID. Okay, so our plan's good. There's probably not going to be a lot left standing. I guess there's not much left to destroy anyway, but it's pretty much a whole new environment. I mean, we got all 3 new virtual networks, 3 new bastion hosts, 3 new subnets, everything. I think the only thing that's the same is Key Vault. Okay, it looks like our environment might be ready. Let's go check on some things. So yeah, as you can see, we have our 3 regions represented here, and each one of these Minecraft servers has their own public IP address that I can go and connect to through the Minecraft client. But that's pretty much how you can take a module and you can stamp it out across multiple regions, which gives you a lot of power in terms of scaling and not in terms of load balancing across regions, to give you high availability and broader reach for your applications. Now, Minecraft doesn't work exactly like that. There's no load balancer happening here. But this example does show you how leveraging modules, Terraform modules, can help you stamp out your environment at a region level as many times as you need to in a very consistent way, and still use shared infrastructure, like Key Vault and things like that, to make it common across, so that from an operation standpoint, everything's streamlined. Even though you're deploying and increasing your surface area across the platform. So I hope you enjoyed this content. I've got a lot more stuff planned with Terraform modules and talking about their design and design patterns and different techniques, and we'll be doing this kind of refactoring process with different resources as well, not just virtual machines. So a lot more fun stuff to come with Terraform modules. So I hope you liked this video. If you did, smash that like button, and don't forget to subscribe and hit that notifications bell so you can be made aware of the next time I drop a video. Until next time, thanks again from Azure Terraformer, signing off. Cheers.